Okay, so get this. AI that can write mathematical proofs. Like, actually write out the whole step-by-step explanation, just like a mathematician would.
Yeah, it's pretty wild.
Blows my mind. And that's what we're diving into today, right?
Absolutely. We're looking at this paper, DeepSeek-Prover, Advancing Theorem Proving in LLMs Through Large-Scale Synthetic Data. And let me tell you, this is some seriously cool stuff happening at the cutting edge of AI and math.
So to wrap my head around this, it sounds like we're talking about AI that can not just solve math problems, but actually explain how it arrived at the answer.
Exactly. And that explaining part, that's the proof. It's like the difference between solving a Sudoku puzzle and being able to show someone else the logic behind every single number placement.
Okay, I'm starting to see why this is such a big deal. But how do you even begin to teach an AI to do something as complex as writing a mathematical proof?
That's the real challenge. And for a long time, one of the biggest hurdles has been data, or rather, the lack of it. See, to train an AI, you need a ton of examples in a language it can understand, right?
Makes sense. You can't just feed it a bunch of textbooks and expect it to magically start writing proofs. So what's the solution?
This is where things get really clever. The creators of DeepSeek realized that they needed to find a way to translate those complex mathematical concepts into a language that an AI could grasp. And they found the answer in a rather unexpected place.
Okay, you've got my attention. Don't leave me hanging. Where did they find this magical data source?
High school math competition problems.
You're kidding. Those insanely difficult problems that most people wouldn't even attempt.
Yep, those very same ones. Think about it. Those problems are already designed to be challenging, requiring rigorous logical thinking and problem-solving skills. Plus, there's a huge amount of them out there, just waiting to be tapped into.
So they saw this gold mine of potential data, but how did they actually use it to teach an AI to write proofs?
Well, the key was translating those problems into a format that the AI could actually work with. And that's where something called formal proof languages come in.
Formal proof languages, I'm not familiar with those.
Basically, they're like coding languages for math. They provide a very structured and precise way of writing out mathematical arguments.
Ah, I see. So instead of using ambiguous words and symbols, it's all laid out in a way that the AI can easily process.
Exactly. And the beauty of it is, once these problems are translated into formal proof languages, they become a treasure trove of data for training AI. The creators of DeepSeek took almost 1 million of these math competition problems and used another AI to convert them into these formal proofs. So it's like giving the AI a crash course in advanced mathematics, but instead of using textbooks, it's getting this massive structured data set of practice problems.
Okay, that's seriously impressive. But how do we know that the AI is actually learning from this data and not just spitting out random formulas? I mean, math is all about precision, right?
Absolutely. And that's where DeepSeek gets even more impressive. They implemented 2 clever strategies to ensure the quality of the AI-generated proofs: a quality scoring model and a hypothesis rejection strategy.
Okay, I'm intrigued. Break those down for me. What do those strategies actually do?
So the quality scoring model acts like a filter. Imagine a really, really picky math teacher who only assigns the most challenging and interesting problems. That's what this model does. It goes through all the potential problems and selects the ones that are actually going to push the AI to learn and improve.
So it's like separating the wheat from the chaff, making sure the AI isn't wasting its time on problems that are too easy or don't teach it anything new. Clever. What about this hypothesis rejection strategy?
Right, so this one is all about training the AI to spot those trick question scenarios, those problems that seem solvable but are actually based on a false premise.
Ah, I see. It's like trying to prove that the Earth is flat. You could spend a lifetime trying to find a proof, but you'll never get anywhere because the starting point is fundamentally flawed.
Exactly. And that's the idea behind this strategy. They essentially challenge the AI to prove the opposite of the given statement. If the AI can do that, it means the original statement was a dud, and they can move on to a problem that's actually worth solving.
That is some next-level AI training. Wow, that's some seriously clever thinking. So they've got their AI, they've got their mountain of practice problems, and they've got a system for making sure the AI isn't wasting time on gibberish. What happens next? Does the AI actually start trying to solve these problems?
It does, and here's where it gets really interesting.
Yeah.
Because even with a mountain of training data, the process of finding a mathematical proof can be incredibly time-consuming.
Right, even for humans. Sometimes you're staring at a problem for days before that aha moment hits.
Well, they figured out a way to make the AI work smarter, not harder. They called it proving in parallel. Instead of just trying to prove the original statement, they also told the AI to try proving its opposite, the negation, at the same time.
So it's like having two AIs working on the same problem from different angles.
Exactly. And here's the beauty. As soon as one side finds a proof, the whole process stops. Because in logic, if you can prove something is definitely false, then you know the original must be true.
Ah, I see. That's a really elegant way to speed things up. So they've streamlined the process, but how well does it actually work? Does this AI actually manage to write any valid mathematical proofs?
It does, and remarkably well. They tested it on two challenging benchmarks, Mini F2F, which is like a greatest hits of tough high school and undergrad math problems,
Sounds intimidating.
and FIMO, which stands for the Formalized International Mathematical Olympiad. So really next level stuff. And the results, well, DeepSeek not only worked, but in many cases it actually outperformed some of the leading AI models out there, including GPT-4.
Wow. Beating GPT-4 is no small feat. We're talking about an AI that can write poetry, code, and now apparently solve complex math problems better than some of its peers. This is incredible. What kind of problems did DeepSeek actually solve?
Let's look at a few examples that illustrate its capability.
Yeah, let's get specific. Give me the juicy details.
So, from the Mini F2F dataset, DeepSeek tackled a classic proof by induction. You know, the ones where you prove something is true for all natural numbers by showing it's true for the first one, then that if it's true for any arbitrary number, it's true for the next one.
Okay, I vaguely remember those from my university days.
Yeah.
They always made my head spin a little.
Well, DeepSeek managed to prove that for any real number greater than -1, a certain inequality involving exponents held true for all natural numbers. It's a pretty standard problem in introductory analysis, but the fact that the AI could construct a formal proof like that is impressive.
Very impressive, so it can handle the fundamentals. What about something from that FIMO dataset you mentioned? Those Olympiad problems are a whole other level.
Absolutely. One example that DeepSeek cracked involved proving the existence of a fraction that falls within a specific range defined by square roots. These are the kinds of problems that trip up even seasoned math competitors, requiring a clever combination of logic and number theory.
And the AI just solved it.
It constructed a formal, verifiable proof, which tells us a lot about DeepSeek's capabilities. We're not just talking about memorizing formulas or crunching numbers. It's demonstrating an understanding of mathematical concepts and the ability to reason logically to reach a solution.
That's mind-blowing. Okay, so we've seen it in action, and it clearly works.
Yeah.
But let's talk about the bigger picture. What's the potential impact of this technology? I mean, why should we care if AIs can write mathematical proofs?
That's the question, isn't it? And it's not just about replacing mathematicians with machines. Imagine this AI tools could be used to check the work of mathematicians, leading to more accurate and robust mathematical discoveries.
So fewer mistakes slipping through the cracks. That makes sense, especially as math gets more and more complex. What else?
Education. Imagine AI tutors that can not only guide students through solving math problems, but also explain the underlying logic and reasoning behind each step. It could revolutionize how we teach and learn mathematics, making it more accessible and engaging.
I love that. It could be a game changer for students who struggle with abstract concepts. Instead of just memorizing formulas, they could actually understand the why behind the what.
Exactly. And on a broader scale, this technology could have huge implications for fields that rely heavily on mathematical models and proofs, things like physics, computer science, engineering, even economics.
It's like this AI is opening up a whole new world of possibilities, not just within mathematics itself, but in all these different domains. This is seriously exciting stuff.
It really is. And, we're just scratching the surface. The researchers behind this paper have certainly opened up a fascinating new avenue of exploration.
It does feel like we're on the verge of something really big here. What's next? Where do we go from here?
Well, imagine a future where AI isn't just proving existing theorems, but actually helping us discover entirely new areas of mathematics.
Okay, now that is both exhilarating and a little bit terrifying. It's like we've given the AI the keys to the math department, and now we get to see what amazing things it unlocks.
And we get to be a part of that journey of discovery. It's a truly remarkable time to be following the world of AI and mathematics.
Absolutely. Well, if you'll excuse me, I need to go find the nearest whiteboard and attempt to process all of this incredible information.
I hear that. But hey, before we wrap up, let me leave our listeners with this thought. If AI can learn to write proofs like this, what other complex human skills might it master in the future? The possibilities, much like the world of mathematics itself, seem truly infinite.
And on that note, we'll wrap up this deep dive into the world of AI-powered theorem proving. If you're as fascinated by this research as we are, be sure to check out the show notes for a link to the original paper. And until next time, keep exploring, keep questioning, and keep diving deep.